Okay, guys, let's continue on with Chapter 8. Again, we're learning about waves. Before we start this lesson, I want you to have a couple things out. Your Chapter 8 guided notes, and you're going to need a calculator today. Today we're going to do a lot of wave calculations. We're going to quantify waves. If you've learned anything in physics, hopefully you've learned that in physics we want to quantify everything. We want to put a number and calculate everything. And so that's what we're going to do today. So let's start with wave properties that we've got to know before we get to those calculations. Wavelength. We're going to study wavelength and calculate it today. Wavelength is given this symbol. It's kind of a funny looking symbol. It looks like an upside down Y. It's a Greek letter. It's called lambda. So if I ever say lambda, that's what I mean. This is the symbol. It's wavelength. So what is wavelength? Well, its name implies length of a wave. It's pretty much self-explanatory. But how do you find it? Here's the important part. It's the distance between two identical points on a wave. So for example, if you're going to measure from one crest, where's the next wavelength? How do you measure a wavelength? Yeah, you go over to the next crest. But couldn't you also do it from trough to trough? Yes. And the units for wavelength, it's distance. So what are the units? Meters. All right, the second wave property is called amplitude. This is the maximum displacement of the medium from the rest position. So if I draw a wave here, the rest position is the origin. The amplitude is the distance from the origin to the top of the wave, the crest. But you could also measure it from the origin down to the trough. So it's how tall the wave is from the origin. Okay, frequency. This one's going to be very important. Frequency is given as finally a symbol that makes sense, right? F is the symbol for frequency. It's the number of waves that pass by per second. So if you look at the units for frequency, it's waves per second. Waves divided by seconds. But you will never see that in physics textbooks. Most physics textbooks will write the units as what? Hertz. It means the same thing. Hertz is waves per second. Okay, we're going to learn about period today. Period is given a symbol that doesn't make sense. Capital T. It's the time required for one complete wave to pass by a position. If you look at the units for period, it is seconds per wave. Guys, how do these two wave properties relate to each other? Look at their units. How do they relate? They're opposites or they're inverses. Aren't they the inverse of each other? If you see here, frequency is waves per second, period is seconds per wave. So if you found one, did you find the other one already, basically? Yeah, you just take the inverse of it. Okay. So let's get started. We're going to do some calculations with these wave properties. Let's look at a wave first. Identify the wavelength and the amplitude. So if we start here at the crest, one wavelength over, you've got to go to the next crest. Okay, but here's where students will get in trouble calculating wavelength. If we imagine that there's an origin here, this rest position of the wave, here's where students mess up. They'll measure a wavelength starting here. And they'll say that the distance from these two dots is a wavelength. Guys, is that a wavelength? No. How come? It's not. It's the distance. So wavelength is the distance from identical points on the wave. If you look here, at this point, the wave has this motion. Where's the next place that the wave is going like this? Well, it would be right here. Okay? So if you are measuring from the origin, be very careful. What I would suggest is just find two crests and measure it from crest to crest. Okay? But if you wanted the origin, then you could do crest to crest and then slide it down that wave and go to the origin. Okay, so just be careful with that. Amplitude. It's the distance from origin to crest. You could also do origin to trough. Okay, practice problem number 4. I want you guys to think about this. Here's a wave, and it says which letter corresponds to the amplitude of this wave? Yeah, amplitude is the distance from the origin to the crest, so hopefully you're saying D. Okay. Practice problem number 5. Which letter corresponds to the wavelength of this wave? Yeah. This one's measuring from trough to trough. Is that okay? Yeah. So B is the wavelength. Okay, now let's talk about frequency for a second. If you just think about the word frequency, it's how frequent the wave is. So I know the answer is here, over here on the right side, but which wave is the most frequent? So when I say frequent, it's how many waves are there in a given space. Isn't there just more waves here? This top one's kind of a lazy wave, right? So lazy waves have low frequency. But if they're very frequent, so there's a lot of waves in a given amount of space or time, we say it has a high frequency. Now which one of these waves do you think has the most energy?
High. Low.
Which one has the most energy, do you think?
High. Medium.
Energy is directly related to frequency. So that bottom wave is going to have the most energy. Lazy, low-frequency waves have low energy. Okay? And I can demonstrate that on this rope. Which wave has the most energy? This lazy one or the one with more frequency? And you can see it that way. All right, so remember, energy is related to frequency. All right, let's start our calculations here with our waves. Let's talk about the difference between period and frequency. Let's start with frequency. In your books, I think you're supposed to write down the formula for finding frequency. Frequency is equal to the number of waves divided by seconds. So it's waves per second. So it's the number of waves that go by in 1 second's time. But in physics textbooks, what are you going to see the units as? Hertz. Does it mean the same thing, waves per second? And it does. It means the same thing. Okay, now let's contrast that to another wave property called period. It's period is given the symbol t. So period is equal to the time. So now we're doing seconds divided by waves. So it's the number of seconds it takes for a wave to go by. Now, like it says down here, frequency and period are inverses of each other. Inverses. Guys, let's just review what an inverse is. If I give you the number 5 and I ask you for the inverse of 5, what is the inverse of 5? 1 over 5. So all you have to do to take the inverse is put 1 over the top of that number. So frequency and period are inverses of each other. So frequency is equal to 1 over t. Frequency is equal to 1 over the period. And period is equal to 1 over frequency. So if you find one, all you have to do to find the other one is take the inverse of it. Right? Okay, so let's do a practice problem with this sort of a question. Practice problem number 6. Let's go through this one together. It says, suppose that 12 waves pass by in 30 seconds. What is the frequency of these waves? Also find the period of the wave. So, what I always like to do, guys, is underline what they give us. 12 waves pass by in 30 seconds. Circle what they want us to find. Frequency, and then after we find frequency, we're going to find the period. So, help me out. Frequency, how do you find frequency? Isn't it the waves over seconds?
Yeah.
Waves over seconds. It's the number of waves that go by in a number of seconds. So how many waves went by? 12 waves.
In 30 seconds.
And it took 30 seconds for that to happen. Okay, so let's put a number to that. So 12 divided by 30 is 0.4. 0.4. Now, what are the units? Hertz. Hertz. Okay. Now that I've found the frequency, how am I going to find the period of this wave? Isn't it just the inverse? So t is equal to seconds divided by waves. So wouldn't it be 30 divided by 12? Okay, what is that? Perfect, 2.5. So what are my units? 2.5 what?
2.5.
2.5, and the units for period is seconds. Seconds per wave. Seconds per wave. So a couple of ways you could do that. Couldn't I have said that the period is equal to 1 over the frequency here, and taken 1 divided by 0.4, and that would have given me 2.5? Sure. There's a lot of different ways you could do it. Okay. And we got it right. Practice problem number 7. I want to go through this one with you too because it's a little bit different in how they ask it. It says a pendulum bob, which is the little weight at the end of a pendulum, completes one cycle there and back. So here's my pendulum. If I let it go there and then back, that's one cycle. It does that every 1.5 seconds. And it says, what is the frequency of the pendulum and also the period of the pendulum? Okay, so let's try this one. Frequency is usually waves per second, but is a pendulum a wave or is it a cycle?
Cycle.
So let's call it a cycle per second. How many cycles did it go through?
1.
One cycle, there and back. How many seconds did that take? 1.5. So what is 1 divided by 1.5? Yeah, it's 2/3, so 0.6 repeating. I'm just going to round it to 0.67. What are my units there for frequency? Hertz. So please put that. Capital H, lowercase z. All right, now let's do this one a little different than we did last time. If we know the frequency, isn't period equal to 1 divided by the frequency?
Yes.
It's the inverse. So let's do 1 over 0.67. What do you get?
I'll tell you. 1.49.
Yeah, 1.49. And that's going to be cycles or seconds per cycles, right? But guys, didn't it tell us that in the problem? That it took 1.5 seconds for every cycle? Yeah, so you could have got that from there. Why is this a little bit lower than 1.5? Because we rounded the frequency here. Yep. Okay, and we got it right. Okay, practice problem number 8. I would like you guys to try this one. Start thinking about these things on your own. So if you're watching the video, please read it and try it on your own. When you've got the frequency of these waves, then hit play again. Okay, so hopefully you guys have an answer at this point, and here's how I would go about it. Okay, it says you observe waves that have a period of 2.5 seconds and a wavelength of 0.2 meters. And it says, what is the frequency of these waves? Well, guys, how is frequency and period related?
Inverse.
They're inverses of each other. Okay, so frequency and period are inverses of each other. It told us the period. So doesn't frequency, guys, equal 1 over the period?
Yeah.
That's what I would do. And so I would do 1 over the period, and that would tell us the frequency. So let's try that. 1 divided by the period was 2.5. What is 1 divided by 2.5? 0.4. Now, it's frequency, so what should I put the units as? Hertz. Okay, by the raise of hand, how many of you guys got that? Very good. And we got it right. Very good. Okay, number 9. So you observed 16 waves pass by in 4 seconds. The wavelength of these waves is 2 meters. What is the period of these waves? Similar question. Please try this one on your own. See if you can't come up with the correct answer for the period of these waves. Please hit pause. Okay, so if you're trying to find the period of the waves, here's how I would go about solving this problem. We need to find frequency. Frequency is waves per second. How many waves went by, guys?
16. Yeah.
16 waves in how much time?
4.
4 seconds. So couldn't I do 16 divided by 4?
Yep.
What is that?
4.
That's 4. That's 4 hertz. But is that what we're supposed to find?
No.
No. So couldn't we do 1 over 4? So period is equal to 1 over the frequency, which is 0.25.
Yes.
Yeah.
0.25 what?
Seconds per wave.
Seconds per wave. Now, there's many ways to do a problem. You might have read that and just put 4 seconds over 16 waves. And maybe that would be easier. Does that give us the same answer?
Yeah.
0.25. Okay, so there's a lot of different ways you can do it. Okay.
I agree.
And look, we got the answer right. Okay, now let's go to a very important section of this lesson. Finding wave speed. I'm going to ask you a ton of questions on the test about calculating wave speed. So let's go through some of these examples. The speed of a wave. We're going to use this equation to calculate the speed of a wave. In your books, I'm pretty sure you have to write it down. Here's the equation. The speed of the wave, so we're talking about velocity, is given the symbol v. We've used velocity all year. You should know that. Is equal to, what is this symbol right here, this upside down y? Lambda. Lambda is a Greek letter, which means what? Which means wavelength. Good. And then this F means what? Frequency. So V equals lambda times frequency. That's how we calculate wave speed. Let's look at this for a second. What are the units for velocity, guys?
Meters per second.
Meters per second. What's the units for wavelength? Meters. From crest to crest, we're measuring in meters. And let's times that. What's the units for frequency? Well, it's waves per second. So what do you get when you take meters and times it by per second? You get meters per second. So that's how you get the units. Okay. Now remember, mechanical waves can travel at different speeds. Some are slow and some are kind of fast. But electromagnetic waves always travel at the same speed. What do we call this speed? The speed of light. Do you guys know what the speed of light is? Yeah, speed of light is given the symbol c, and it's 3 times 10 to the 8th meters per second. Speed of light. Okay, practice problem number 10. Let me go through this one with you. A sound wave with the frequency of 262 hertz has the wavelength of 1.29 meters. What is the wave speed? Okay, so it gives us a couple of things. Frequency, I would like you to underline that. Wavelength, underline it. We're trying to find the wave speed, so I like to circle that part. Now let's write down the equation for wave speed. V is equal to what, guys?
Velocity.
Yeah, it's velocity, but what does it equal?
Meters per second.
Well, that's units are meters per second, but what does it equal in the equation?
Oh, wavelength times frequency.
Wavelength, so lambda times frequency. Please write that down. Please write it down. Now let's plug in our variables. Okay, we don't know velocity, so we're just going to keep calling it v. What is this funny looking symbol? This upside down y? Wavelength. What was it? 1.29 meters. So 1.29 goes there. Make sure you're in meters, and we are. And frequency. What's the frequency? Did it give it? 262 hertz. 262 goes in there. Now, if you times those two numbers together, does that tell you how fast the wave's going?
Yeah.
It does.
337.
Okay, did you guys get this number? 337.98.
Yeah.
Now, can I just round that since it's so close? What should I round it to?
38.
338. And what are my units?
Meters.
It's velocity, so it's meters per second. So that wave's going pretty fast, isn't it? Wave's going pretty fast. Okay, and look, we got it right. Okay, number 11. This is an interesting question because it's actual data. Your microwave oven at home, this is the data off of it, okay? The speed of light is 300 million meters per second. What is the frequency of microwaves with a wavelength of 0.01 meters? That's 1 centimeter. Just about what they have. I would like you guys to tell me what the frequency of microwaves are. How many waves are there in 1 second? I think it will surprise you.
300.
Try it on your own, okay? Try it on your own. If you're watching the video, please hit pause. Okay, let's see how you did. Hopefully you have an answer at this point. But it's giving us the speed of light, which is the speed of microwaves. It's given us the wavelength of the microwaves. And it's asking us for the frequency. So I would write that equation down. The speed of a wave, the velocity, is equal to wavelength times frequency. Did it give us the velocity of these microwaves? Yeah, they travel at the speed of light, 300 million meters per second. Is equal to, did it give us the wavelength? And it did, 0.01. And we just got to figure out what the frequency is. Okay, so how do I solve for f right there? Divide by 0.01 on both sides. Okay? And so frequency is equal to 300 million divided by 0.01. What does that equal, guys? 3 times 10 to the 10th? What are my units going to be? Hertz. That's waves per second. So microwaves, do they have a high frequency or a low frequency? Very high. Imagine 3 times 10 to the 10th waves per second. So I mean, these things are just very high frequency. And what did we say about frequency? How does that relate to energy? They're directly related. So if you have a high frequency, what about energy? They're high energy. And that's how it cooks your food in your microwave oven. Okay, that's how it's cooking your food. High energy waves. But did you know that microwaves are just light? It's just light, but we can't see them. The wavelength.
Wait, you cook stuff with light?
Yes. Electromagnetic radiation. We'll get to that. Okay, number 12. Let's try it. Okay, again, I would like you to read this on your own. try to answer the question, see if you can't get it right on your own. If you're watching the video, please hit pause.
Okay.
Okay, let's see how you guys did with this. So the average wavelength of a series of ocean waves is 15 meters. So wavelength is 15 meters. A wave crest arrives at the shore on average of every 10 seconds. So the frequency is 0.1 hertz. What is the average speed of the wave? So you're sitting at the beach, and you've timed these waves, and they crash into the beach every 10 seconds, and you measured kind of their wavelength. Let's figure out how fast they're going. So if we're going to get the average speed of the wave, let's write down that equation. V is equal to what, guys? Wavelength times frequency. Now it didn't tell me the speed. That's what I'm supposed to find, so I'm going to call it V. What was the wavelength? Did it tell us? 15 meters. So 15 goes in there. And what was the frequency? 0.1. 0.1. Guys, so what was the speed of these waves?
1.5.
Good. 1.5. What's the units? Meters per second. That seems reasonable. Oh, maybe it's a little bit slow, but it's 1.5 meters per second. Okay.
That's like a tsunami. Tsunami would be pretty fast.
Okay, here's an interesting question. Radio waves. Okay? This wants you to calculate the speed of an FM radio wave that's going into your car's radio. Let's see how fast they're going. Okay, so please try this one on your own. If you're watching the video, please hit pause and try it. Okay, so at this point, hopefully you tried it on your own. You have some sort of an answer for how fast these radio waves are going. So an FM radio station broadcasts electromagnetic waves at a frequency of 94.5 megahertz.
Whoa.
Guys, did you know that in your car, when you tune it to a radio station, so this is 94.5, that's just the frequency of the waves. So you're just tuning it to that frequency so that you pick up waves of that frequency. But they're not just hertz, it's megahertz. So it's times 10 to the 6th hertz. So this would be 94,500,000 hertz. That's a lot of waves per second. The radio waves have the wavelength of 3.17 meters. What is the speed of the wave? So let's go to that equation for speed of the wave. So V is equal to wavelength times frequency. And plug in. What was the wavelength, guys? 3.17. What was the frequency of these radio waves? 94,500,000. Okay, when you put that in your calculator, you're going to get a number very close. It's going to be very close to 3 times 10 to the 8. Did you? Okay, it's very close to that. I rounded up a little bit. But what are my units going to be? Meters per second. Guys, you should recognize this speed. What is it?
Light.
Speed of light. So radio waves, that's how they can get from where they're broadcasting them to your car. Almost instantly, they're going the speed of light. But interesting, hopefully you guys remember that when you turn your radio dial to another station, all you're doing is telling your radio to pick up waves of different frequencies. So, and this also means, doesn't this also mean that radio waves are light?
Yeah.
It's just a different form of light that our eyes can't pick up. There's radio waves going through this room right now. We can't see them because our eyes just don't pick up those wavelengths. Okay, real quickly, I wanted to do a section on echoes. Echoes are cool, right? We've all experienced with echoes and have yelled and heard your echo come back to you before, right?
Echo.
So let's do this problem. Sound waves travel about 340 meters per second. That's about 760 miles per hour. So they're fast, but are they as fast as light? No, not even close. So if you stand 100 meters away from a cliff, how long would it take for the sound wave to travel from your position to the cliff and then back again? So let's draw this picture. Here you are. Okay? Let's say the cliff is over here.
1.5 seconds.
How far is that cliff, guys?
A lot.
How far is it? 100 meters. Okay, now we got to think about this. If you shout, so here's your shout, it's going to travel at what speed?
340 meters per second.
340 meters per second. Now, in order for you to hear the echo, what do these sound waves got to do? Well, they got to go here, and then they're going to be reflected off that, bounces off that cliff, and comes back to your ears. Speed. Here's how we calculate speed. Isn't it really a distance divided by time? Okay, so let's do that. What was the total distance that these waves have to travel? 200. Yeah, you got to go 100 there and 100 back to your ear. So that's going to be 200. How much time will that take? Well, we don't know. I'm just going to put seconds down here. And how fast are these waves going? 340. Okay. So if we're going to solve for the time that it takes for you to hear your echo, that's how you would set it up. Now, how do we get seconds off the bottom? Times both sides by seconds. And then how do we get the 340 off this side? Divide by 340. So my seconds cancel out, and then my 340 is on the bottom. Okay, so seconds is equal to, what was it, 200 divided by 340? 0.6? 0.6. What does that mean? 0.6 what? Seconds. So it would take just over a half a second for you to hear your echo. Hopefully that makes sense. Practice problem 14 is kind of like that. I would like you to try it on your own, so please read it. See if you can't solve this question on your own. So if you're watching the video, please hit pause. Okay, so hopefully you have an answer. Let's read through and see how I would approach solving a problem like this. It says the speed of sound is 340 meters per second. If you hear a collision 3 seconds after you see it, how far from you is the collision? I think we've all experienced this before, right? Where you see something happen and then a short time period later you hear it happen. How come? The speed of light is a lot faster than the speed of sound. So if you ever go to a baseball game, you ever sit like way back in left or right field, and you watch the batter hit the ball, you'll see him hit the ball before you hear the crack of the bat, won't you? Yeah. We've all experienced that. And so that's what this question is kind of like, except for you saw a collision, and then 3 seconds later, you heard it. So we're really trying to figure out how far away the collision was. So let's go back to that equation. Speed is equal to a distance divided by time. What's the speed of sound? The speed of the sound waves was what? 340. Do we have the distance? We didn't have the distance. How much time did it take you to hear it? 3 seconds. Okay? So how would I solve for distance here, guys? Times both sides by 3. Over here it cancels out. So the distance is equal to 1020? Is that what it was? 1,020 what? It has to be meters. So that's kind of cool. We can figure things like that out. All right. Guys, how many of you got it right? Just curious.
I got it left.
I've got a couple of practice problems left. Let's go back to the wave speed calculation equation that I taught you earlier. Okay? So practice problem 15. Try it. Read it. Try it on your own. See if you can't get it right. Okay, so hopefully you have an answer at this point, but here's how I would go about solving this problem. We're trying to get the speed of the wave. So let's go back to the speed of a wave equation. Velocity is equal to, what's the symbol again, this funny looking Y?
Lambda.
Lambda, which is wavelength times frequency. Okay, I don't have the speed of the wave, so that's V. What's the wavelength? Did it tell me?
0.2.
Wavelength is 0.2, so I'm going to put 0.2 in right there. And now all I need is frequency. Did it tell me what the frequency was? It didn't. But it did tell me the period was 2.5 seconds. How can I get frequency out of period? Good. Frequency is equal to 1 over period. So if we want to find the frequency, let's just take 1 over. The period was 2.5 seconds. What does that equal? 0.4. And that's frequency, so what are my units here? Hertz. Is that my answer? No, that just goes in here for frequency. So 0.4 goes here. Velocity is equal to 0.0 what? 8. And what are my units? Meters per second. Curious, how many of you guys got it right? Okay, very good. Last one, guys, and then we're done. Okay? Practice problem 16. Please read it. Please try it on your own. Come up with an answer. If you're watching the video, please hit pause until you have an answer. Okay, again, guys, hopefully you have an answer at this point. If I was to do this problem, I would do it this way. I would circle the speed of the wave. That's what we're supposed to find. So I would write down the speed of wave equation. Velocity is equal to lambda times frequency. And let's plug into it. Did it give us wavelength? Yeah, it says the wavelength was 2 meters. Did it give us frequency? It didn't come right out and give us frequency, but can we calculate it? It says you observed 16 waves in 4 seconds. Guys, if you remember, frequency is waves per second. Okay, so let's do that. 16 waves in 4 seconds. Guys, what's 16 divided by 4? 4. It's equal to 4. And the units? Hertz. That's my frequency, which I'm going to plug in here. 4 goes right there. What's 2 times 4?
8. 11.
8. And what are my units?
Meters per second.
Meters per second. Okay, that's it for the lesson. Hopefully, guys, you know how to identify the different properties of a wave. Mostly, how to calculate wavelength, amplitude, how to find the frequency and period of a wave. And also, very important, the speed of a wave calculation. I'm going to be using that a lot in the coming lessons. So, to give you some more practice with this, I've got 3 worksheets in the student workbook. The first one that I would like you to do is titled Labeling Waves Worksheet. The second one, Period and Frequency Worksheet. And the third one, Speed, Frequency, and Wavelength Worksheet. So please go there. Let's complete those worksheets. Give yourself some more practice with this, and hopefully this video helped.